All right, finishing up our geometry review. Our Chapter 7 test is Friday. What is tomorrow, the 17th? Yeah, Friday the 17th. There's another video with the 1 to 20. Tomorrow when you walk into class, you got to be ready to turn in all of your review. We'll get those stapled up today after we finish going over it. You'll have your graphs and lined paper attached to this review packet. All of your Chapter 7 notes need to be turned in tomorrow. Make sure that that's ready to go. If you're missing anything, I made my notes available yesterday. I can make them available again today for anybody needs it. And anybody that has any late or missing work that hasn't already gotten to me. If you gave me missing work yesterday, it is already in the grade book. I did that yesterday afternoon. So we're picking up on number 21. We're picking up on number 21. We got to 1 through 20 yesterday. In problem 21, I'm looking at a trapezoid sitting right here, and that trapezoid is marked, the legs are marked congruent to each other, and since these legs are marked congruent to each other, we got that isosceles idea, and I do know that in an isosceles triangle, base angles are going to be equal to each other. So one of the things that I've got right now is saying that the measure of angle Z is equal to 58. And then I go back to the idea that in any four-sided figure, the sum of the angles is 360. So if I do 360 minus those two 58s, I'm left with 244 degrees to split between these two angles. And so 244 split between those two angles is leaving me with 122 for both of these. The measure of angle W is 122, and the measure of angle X is 122. And you know what? They gave us, I'm going to put it up top, the measure of angle Y was 58. That was the given that we started with. So knowing one angle in an isosceles trap, you can go through that process and get all the rest. Now in 22, this is a mid-segment, and it's the trapezoid that's sitting here. This trapezoid's bases are at the top and the bottom. It is kind of upside down if you consider how like a trapezoid, like a natural trapezoid sits on the longer side typically. Mid-segment is found by just taking half of the sum of the bases. 39 and 13 are the bases. So that's given me the half of 52, and half of 52 is 26. So the mid-segment for that is 26. Now 23, you have to find the mid-segment of a trapezoid that's graphed. I had the graph prepared. 23, boom. So what I need to do here in 23, this is the JKLM trap. J is sitting at 610, and I'm putting these on here because I'm going to use them for some calculations. K is sitting at 10 and 6. L is sitting at 8 and 2. M is sitting at 2, 2. Now, if I have to find the length of the mid-segment, what it means then is I actually need to figure out what these bases are. So I need to find the length of the bases and then use the mid-segment formula. So let me do the base that's over here. How long is J to M? The green one. I've got one ordered pair is 610, the other one is 2, 2. When I do how far apart, I get 8 and 4. So then J to M is equal to 4 squared plus 8 squared. That's going to be the square root of 16 plus 64. That's the square root of 80. I may simplify that down in a minute, but right now I'm going to leave it as square root of 80. So that's my base over here is square root 80. And then I've got to go get the other one, the K to L. Got my X and Y for K to L, 10 and 6, 8 and 2. This is 4. This is 2. This is going to be equal to 2 squared plus 4 squared. That's going to be equal to 4 plus 16, so that's the square root of 20. So this base is square root 20. And then I'm actually going to go in my calculator and I'm going to go get an estimation. So the mid-segment then is, again, same thing I did on number 22 with mid-segment, half of the sum of these bases, square root 80 plus the square root of 20. Bless you. And I'm going to go into my calculator with that. And the only thing that I'm going to do in my calculator is when they open up parentheses, I'm going to put all these parentheses, When they open up parentheses for our square roots, you want to just close them up. So there's going to be multiple. I'm going to put my fraction out front in parentheses. Let me clear my screen. So my 1/2, 1 divided by 2 is going in parentheses. I'm opening up parentheses and I'm going to do the square root of 80. I'm going to close that. I need to add to that the square root of 20. I'm going to close that. And I actually need to close off the parentheses that I opened in the whole thing. The mid segment in this case has a length of, and I'm going to change this to an approximate sign, of approximately 6.7 or 6.71. So this one had plotted, you had to get mid-segment. In order to get mid-segment, I need those lengths. Length, half of the sum of the mid-segments brought us to 6.7. 24. A kite has angle measures of 7x, 65, 85, and 105. Find the value of x and what measures of the angles are congruent. Now in a kite is four-sided. So for a kite being four-sided, the sum of the angles is going to be 360. So what we have is 7x and 65 and 85 and 105 has to be 360. When I go and put together the 65, 85, and 105, I'm getting 7x plus 255 equals 360. I'll take 255 away from both sides. When I do that, I'm left with 7x's is equal to 105. When I divide by 7, I'm getting down to x is equal to 15. Now, that missing angle, 7x, was 105. They said, what are the measures of the angles that are congruent? That missing one was 105. We had another 105. So actually, add a little drawing here. Add a drawing to your number 24 with these measures here. So we got down to the two that would be the congruent pair across from each other, and then the other two angles aren't congruent in a kite. For problem 25, Trevor, get up and move up here. This second seat is yours permanently. Quadrilateral 25, quadrilateral WXYZ is a trapezoid with one pair of congruent base angles. Is that an isosceles trapezoid? First thing I'm going to do is draw what they're telling me. Little sketch here, quadrilateral WXYZ. And it's got one pair of congruent base angles. Now it's asking, is it isosceles, and explain your reasoning. You guys will have all of your theorems for your test tomorrow. And when I go into 7.5, where we looked at work on trapezoids, theorem 715, the isosceles trapezoid base angles converse tells us if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. It's theorem 715, and I'm most interested always in what the names of these are. The isosceles trapezoid base angles converse justifies that this is isosceles. It's got a pair of base angles congruent, which is tells me that those sides are congruent. Trapezoid base angles converse. And again, you will have a list of all the theorems for your test, so you can get at what those statements need to look like. I'm not thrilled about numbers, but I know with the numbers it's easier to find them in your notes. 26, 27, and 28. Give the most specific name for the quadrilateral and explain your reasoning. In these problems, again, this is where, and we tackled some of these, I think, yesterday when we were going over our 7.5 work. For 26, the first thing, the only thing that I'm going to do on these is I'm going to identify what it is that's marked. So in 26, there's exactly one pair of parallel sides. There's exactly one pair of parallel sides. So this must be a trapezoid by definition, because that's the definition of a basic must. So this must be a trapezoid. It's not isosceles, but it's a trap. Now in 27, I see that all four sides are congruent. The most specific name I can give this is a rhombus. I don't see anything about angles being 90. So the only thing I can conclude is that this is a rhombus. Now in 28, making statements about what I see. All angles are 90 degrees. And both pairs of opposite sides are congruent to each other. So again, I'm just writing down what the markings on the drawing say to each other. So this is a rectangle. This is a rectangle. The markings have the definition of a rectangle in it.